Good afternoon, friends. Last lecture we have to discuss about the synthesis of titanium dioxide. Okay. In this lecture we have to discuss the second last nanomaterial is about the synthesis of Fe2O3. Okay. Synthesis of Fe2O3 nanoparticle. Okay. Its aim is about to synthesize the iron oxide particle of different shapes. Synthesize the iron oxides, okay, that is that to synthesize the iron oxide means Fe2O3, that is a iron oxide, that to synthesize the iron oxide particles means iron oxide particle of different shapes, mean different shapes they have to synthesize the iron oxide particle. Okay, this is the aim of these nanomaterial nanoparticles, that is about synthesis of the Fe2O3. Okay, its chemical is about the NaOH, ferric chloride, sodium hexa metaphosphate, then double distilled water. Okay, this is this chemical you have to use in the synthesis of Fe2O3 nanoparticle. Okay, equipment. Therefore, the two equipment that have used in the synthesis of Fe2O3. First is the RBF, that is the round bottom flask. Then secondly, the magnetic stirrer cum heater. Okay, this is the equipment you have to use in this synthesis of Fe2O3. Okay, in the procedure, therefore this procedure it is useful to form the Fe2O3 particle. Okay, the first is take the RBF. In this RBF, therefore, you have to firstly prepare the 0.5 molar NaOH. You have to firstly prepare the 0.5 molar NaOH solution in distilled water. Solution in distilled water means you have to prepare the 0.5 molar concentration. You have to prepare the 0.5 molar concentration of NaOH in distilled water. 0.5 molar concentration of NaOH in distilled water, you have to prepare this solution. Then in this solution you have to add 0.01 molar solution of ferric nitrate. 0.01 molar solution of ferric nitrate. Okay, then after this preparation of this 0.5 molar NaOH solution, you have to add the 0.01 molar solution of FeNO3 thrice, that is the ferric nitrate. Okay, then after the addition of the ferric nitrate, then the stir till the pH become 8.7. Stir pH become approximate 8.7. Means after the addition of the 0.01 molar of FeNO3 thrice, therefore you have to stir them, and after the stirring, therefore its pH becomes, means your solution pH becomes, it is approximate 8.7. Okay, then after pH you have to check, then add the 1 molar HCl. After the pH you have to check, then add 1 molar of HCl into this solution. Therefore again stir. You have to add 1 molar HCl. Then again to stir this solution. Therefore you have to add again 0.1 molar solution of NaS2PO4. Okay, after the addition of 1 molar HCl solution, therefore you have to stir them, and after the stirring you have to add 0.1 molar concentration solution of NaS2PO4. Okay, after this solution, therefore you have to again stir, then add the water, then add the double distilled water, and therefore this double distilled water we have to add. Then heat at approximate 100 degrees Celsius. Heat at approximate 100 degrees Celsius. Then wash and dry the PPT. In air at 100 degrees Celsius. At 100 degrees Celsius means after addition of the water molecule and heat the solution, therefore the precipitate are formed into this solution. Then you have to wash them this precipitate and dry the PPT in air at the 100 degrees Celsius. This 100 degrees Celsius, it is a room temperature. In this compartment, room temperature in this compartment, that the temperature condition of the drying is about the 100 degree Celsius. Okay, then for different phases, they heat the sample for different time intervals. For different phases, mean different types of the phases, therefore the sample, okay, you have to take the different types of the sample, that sample you have to different time of interval you have to heat it, okay. Then this is all about the procedure of this synthesis of the Fe2O3 nanoparticle. Then lastly, result of the synthesis of Fe2O3 particle, that was the X-ray diffraction analysis can be carried out in determining phase. Okay, you have to XRD, that the XRD of this Fe2O3, that is about it can be carried in determining phase, means XRD in determining phase, and therefore this particle means this Fe2O3 particle, that particle it can be converted into, means Fe2O3 particle can be converted into magnetic particle. Fe2O3 particle that can be converted into magnetic particle, and that magnetic particle it is by annealing them. It is by annealing them the S2 gas. It is by annealing them the S2 gas, and that S2 gas at the 350 degrees Celsius to 370 degrees Celsius its temperature condition, and that have heat the S2 gas at the 2 hours. Heat the S2 gas at the 2 hours. Therefore, your Fe2O3 particle are present, and therefore Fe2O3 particle size is about the 200 nanometer. And therefore this is all about this synthesis of Fe2O3 nanoparticle, its aim, chemical, equipment, procedure, and the result. Okay, this procedure you have to obtain the synthesis of Fe2O3 particle. Next time we are to discuss the last nanomaterial, that is about the synthesis of the porous silica. This is the last point in this nanomaterial particle. Okay, thank you.